Radiation safety is not only for the patient, it is also for a radiographer, doctor, whatever who are working in a radiation department or radiology department or whatever it is related to radiation related department. They should and keep some radiation safety. Okay, for example, radiographer. Every radiographer should wear the radiation apron, lid aprons in CT, X-ray, whatever wherever we require. Okay, doctor also, gloves, glasses, steel glasses. Okay, everyone should wear the radiation safety things, equipments. Okay, thank you so much. Radiation safety. So I would like to tell you some radiation safety. So it is useful for all competitive exams or also for subject views. Introductions. Radioactivity isotopes occur naturally or can be generated artificially. They emit ionizing radiation in the form of electromagnetic waves or energetic particles. Exposure to ionization radiation above the permissible limits can be result in serious biological damage. You can see here, okay, atoms and constituents. All matter is made of atoms, and atoms consist of a nucleus in the center and electrons orbiting around its different cells. The nucleus of the atom consists of the positive charges, protons, and natural particles called neutrons. See here, okay. Radioactive emissions. A radioactivity nucleus is unstable due to an imbalance in the proton to neutron ratio. The unstable nucleus can become stable by injecting particular and electromagnetic waves. If iron loses an orbiting electron, it's becoming a positive ion, as it will have more positive charges than negative charges. The electrons that was removed because a negative ion. Type of emissions. The electromagnetic waves emitted by the radioactive isotopes are alpha, beta, gamma. You know very well. Okay, alpha radiation. Alpha particular consists of two proton and two neutrons. Their range is a in about 10 centimeters. They will not penetrate through the dead layer of the skin. They can be stopped completely by a piece of paper or by clothing worm. Alpha radiation. Alpha source is not a external hazard to the body, but they are a international hazard if it get inside the body through ingestions or by a wound. It's once inside a body, they disintegrate, causing serious damage to the surrounding tissue within 5 microns depth. Next, beta radiation. The beta also particular are electrons which are ejected from the nuclei of radioactivity atom by disintegrations. They can penetrate into the human body from zero point 0.2 to 1.3 centimeters, can travel 5 meters through air. If they are deposited on the skin for long period of time, they could cause severe burn. And beta radiation. Beta emitted is an internal radiation hazard when taken inside the body. When the beta particle is slowed down and stopped, secondary radiation known as breast may be produced. Okay, beta particles can be stored by the walls of a room or by a sheet of plastic about 1.3 centimeter thick. Okay, everyone should make the one notes and note down everything. Okay, gamma radiation. Already I told you gamma rays are electromagnetic radiation of short wavelength that are deep penetrating. Due to the deep penetration, they present an external exposure hazard. They can travel many meters in air. Okay, you can see here penetrate power of radiation alpha, beta, gamma. You can see alpha is upper one, beta is middle one, and gamma is uh, down one. Okay, you can see here paper, aluminum, lead. So gamma radiation can go more distance. Okay, and biological effect of radiation. We have some effect biological and okay, in that one biological effect also it's one. Okay, which is a as radioactive protons or particles pass through the living cells, they cause rupture of a bond in the molecules resulting in a molecular changes that injury the affected cell. This destroys the capacity of introduction in some cells or cause mutations in which are the cells resulting from the divisions are different from the parent cell. A very weak exposure over several years can be as potential injuries as a large single exposure. Okay, biological effect of radiation. An important characteristic of injuries arising from the penetrating radiation is the latent period that inversions and between the exposure and visible sign of its effect. Okay, the time between the exposure and the first sign of radiation damage is called the latent period. The larger the dose, the shorter latent period. Okay, basic safety factors. We have some factors, basic chapter. That's one the external radiation exposure hazard. The basic protection measures are associated with the time, distance, and shielding. Okay, let's I explain time, distance, shielding. Okay, time. Simply, method for the protection from ionization radiation is to spend as little as possible in the vicinity of radiation exposure. This is the applicable when other protection methods are adapted. Reducing the exposure time by the one off, reduce the dose receiving by one off. Okay, we can see here everything and we can note down everything. Okay, distance I will explain about distance. Doubling the distance between the person and the source helps to reduce the exposure to quarter of its original value. Maintaining a safe distance is important when working near and adequately shielded sources of radiations. Okay, I given you short notes, so you should keep it in a notes. Okay, shielding. The more mass it is placed between a source and a person's, the less radiation is the person will be received. Okay, transparent plates of thick and plastic or aluminum is used for the shielding beta particles. Gamma rays can be attenuated by the using lead seals or concrete. Okay, monitoring instruments. Film badges. Okay, the film badges is warm and the outer clothing of the user. It consists of photographic film. The radiation interact with the silver atoms in a photographic film, resulting in the darkening of the film. Okay, the darkening film is compared to the control film that was not exposed radiation to determine the amount of radiation exposure. You can see here image also. Monitoring instruments in the thumb TLG badge. You know very well. Okay, and TLG badge. This means thermoimmunant detectors. Okay, the TLG are normed the person to as a badges are a fingerprint which is consists mostly of lithium fluoride chips. Monitoring instruments. The TLG absorbs the radiation, displaces the electron from their ground state. The electrons are stored in a meta-stable state, and light is emitted when electrons return to the ground state. The amount of light released is realized and related to the absorption radiation dose. Okay, and packet dosimeters. It consists of electrostatically charged quartz fiber and ionization chamber. When chamber is exposed to radiation, the air atoms in the chamber become ionized. This allows the static electric charge to leave from the quartz fiber in direct relationship to the amount of radiation present. The advantage is that it allows the individual to determine his or her radiation dose while working with radioactivity isotopes. Monitoring instruments. Oh, ionization chambers. It consists of ionization chamber with a positive and negative electron. Okay, when exposed to a beam of radiation, a current will be flow in the circuit because the electrons that are knocked out of the air atoms by the radiation will be attracted by the positive electron. Okay, the flow of current will be proportion to the radiation received. Okay, proportion. Okay, and Muller contour. Okay, capable of detecting very small amount of radiation. It is used ionization chamber, but it is filled with a special gas and has a greater voltage supply between its electrodes. You can see here image. Okay, see here, this is one. And now radiation units. Becquerels. The strength of the radioactivity source is measured in a unit of backwards BQ. You can write shortcut BQ. Okay, B is small, B is big, and Q are small. Okay, BQ. It is equivalent to the one designation per seconds. This unit provides a measures of the rate of radioactivity disintegrations. Okay, there are 3.7 into 10 of 10 big for Curie of radioactivities. 10 4 of 10. 3.7 into 10 4 of 10. Okay. Radio units. Absorption dose. The amount of energy absorption per unit weight of organs it is called the absorption dose. It is exposed in a units of gray. Okay, 1 gray is equal to 1 joule of absorption energy further. Rad is the older unit of 1 gray. Okay, 1 and 1 gray equal to 100 rads. Equivalent dose. The equivalent dose is equal absorption dose multiplied by the radiation weighting factor. REM is the older unit of equivalent dose. 1 SQ SV is called 100 REM. Okay, REM. Safety precautions. Lab coats, shoes, and safety glasses must be worn in the laboratory. Safety precautions. It also materials or equipments which are not required must not be brought in the laboratory or stored inside. In inventory of radioactivity sources used, a laboratory must be maintained and updated. Food items must not be stored and consumed into the laboratory. Okay. We can see in every radiology department or whatever it laboratory, or we can see that board causing the radiation area, that is personal only. We can see in front of entrance of radiation department, radiology department. Okay, radiation symbols must be displayed whenever active sources are being mm, manipulated or stored. This is the radiation symbol. Okay, and gloves, clothing, operators and benches must be monitoring after work with the radioactive materials. Okay, safety precaution. Always use appropriate shielding when working with the radioactive materials. Safety precaution. Use remote handling device such as forceps, tongues, wherever possible. Never pipette solution by mouth. Okay. Work's surface must be covered with a smooth and non-absorption material. Thank you. Thank you so much. So please keep watching our YouTube channel. If you um, so keep watching our YouTube channel. So if you think it is better video, so please share to all your friends and subscribe me. So thank you so much.